In this lesson, you guys are going to learn how to utilize the Mole Kingdom flowchart. And you guys are going to apply the Mole Kingdom flowchart's directions so that you can interconvert mathematically between grams, moles, molecules, and atoms. So what we have here, guys, is the Mole Kingdom. The Mole Kingdom is basically just a flowchart that allows you to easily remember what kind of mathematical operations and what kind of conversion factors you're going to be utilizing to interconvert between grams and moles and molecules. So how do we utilize this flowchart? Okay, well, first of all, what you guys need to understand is that it's broken up into various pieces. So notice here we have two different lands. We have mass land and atom land. Mass land represents units of measurements like grams, kilograms, what have you. Atom land represents molecules, atoms, and things of that sort. Okay, and anytime you are in one of the lands and want to convert into one of the other unit types, you're going to use specific math. Okay, so whenever you're going from a land into the kingdom, you are always going to be dividing. So notice this: atom land into the kingdom, you divide; mass land into the kingdom, you divide. Okay, and so you remember this by anytime you want to go into the kingdom, you're going to divide and conquer. Okay, now, depending on where you're coming from, that's going to dictate what you divide by. So if I'm going from mass land into the kingdom, I'm going to be dividing by my molar mass. Okay, and notice my molar mass, the units for molar mass are grams per mole, which match up with the units of the substances that I'm going to be converting between. Okay, now if I was going from atom land into the kingdom, I'm going to be dividing again, but I'm going to be dividing by Avogadro's number. And Avogadro's number is a numerical value that you guys should know. Avogadro's number is 6.022 times 10 to the 23rd. Okay, and so this numerical value, anytime you have a mole of a substance, okay, this is how many of that substance you're going to have. So that's why we have our units here written as species per mole, because it could be molecules per mole or atoms per mole or apples or oranges per mole. It doesn't really matter because there are 6.022 times 10 to the 23rd of any substance in a mole of that substance. Okay, so whenever we are now wanting to go out of the kingdom, so let's say we're starting in moles and we want to move ourselves into one of the exterior lands, we're going to do the opposite math. We're going to multiply. So if I'm in the kingdom and I want to get into mass land, I'm going to multiply by my molar mass. If I'm in the mole kingdom and want to get into atom land, I'm going to multiply by Avogadro's number. Okay, so this is just the basic setup and basic means to utilize this chart. Okay, and we'll use that on the next several problems. So we're going to go ahead and look at taking grams or molecules or atoms and converting them into moles. So basically what we're looking at is taking values from the exterior lands and going into the mole kingdom. So this first problem here asks us how many moles of water are present in 22.2 grams of water. So our given here is going to be our 22.2 grams of H2O. And the thing that we're solving for or converting into is moles of H2O. Okay, and if we look at our kingdom, okay, we notice that first of all our given is in grams, so we know that we're starting in mass land. And what we're trying to solve for is in moles, so we need to go from mass land into the mole kingdom. That means that we are going to be dividing, because in order to get into the kingdom, you need to divide and conquer. And what we're going to be dividing by is the molar mass. Go ahead and take those 22.2 grams of H2O. Okay, and we're going to set up this dimensional analysis problem. We're going to put our given up in that first box, and we're going to put what we want over what we have. So we want to be in moles of H2O, and we are already in grams of H2O. That was our given units. Okay, and so the molar mass of our H2O is going to be 18.015 grams for every 1 mole. If we go ahead and plug this into our calculator, we get 1.232 as our numerical answer. Okay, that numerical answer, there's multiplication and division going on here, so we have 3 sig figs in our original value, so we should have 3 sig figs in our final numerical answer. So 1.23 is going to be the unit or the value that we obtain. And then we're going to go ahead and check our units. Grams of H2O, grams of H2O cancel, moles of H2O are what are left over. Okay, and we subsequently have our answer for this first problem. This next problem, they have asked us how many moles of H2 are present in 1.0 times 10 to the 40th molecules of H2. Okay, so our given here is going to be 1.0 times 10 to the 40th molecules of H2. And the thing we're solving for is moles of H2. Okay, and so particular problem, we're going from molecules to moles. So in this case, we are in atom land, and we're going to go into the mole kingdom. Again, because we're going from one of the lands into the kingdom, we need to divide, but this time we need to divide by Avogadro's number. Okay, and Avogadro's number is 6.022 times 10 to the 23rd species per mole. Okay, and we use species as the generic representation because it can represent anything, molecules, atoms, people, apples, whatever we want to indicate, because 1 mole of anything is going to be equal to Avogadro's number. Okay, so we're going to go ahead and we're going to set up this problem. Okay, so we have 1.0 times 10 to the 40th molecules of H2 as our given. Okay, and we are going to set it up just like we did last time, except in this case, what we want and have are a little bit different. But what we want to be in is moles of H2. Okay, so that's consistent. But we are starting in molecules of H2. So we need to use Avogadro's number, so 6.022 times 10 to the 23rd is what we're going to plug in down here, and our 1 mole up top. We go ahead and we plug this into our calculator. And that's going to go ahead and give us 1.66 times 10 to the 16th. Okay, we have 2 significant figures in this value originally, so our answer should have 2 sig figs, so that's going to give us 1.7 times 10 to the 16th as our value. Units-wise, molecules of H2 and molecules of H2 cancel, and we are left with moles of H2. Okay, so this answer here is our final answer for this particular problem. So when you guys are approaching these, you want to write out your given, your solve for, you want to set up your dimensional analysis problem, you want to analyze your significant figures, and then of course do your unit analysis so that you get the correct final answer. So now that we're accustomed to utilizing the mole kingdom, let's go ahead and apply it to the reverse process. In these problems, we're going to be taking our mole values and either going to mass land or atom land. Okay, so in this first problem here, they are asking us how many grams of H2O are present in a 3.2 mole sample of H2O. So my given here is going to be 3.2 moles of H2O. Okay, and my solve for is going to be grams of H2O. Okay, so we are going from the kingdom out into mass land. Okay, and we know that in order to exit the mole kingdom, we're going to multiply, and in this case, we're going to multiply by the molar mass. So we're going to go ahead, we're going to set this up, we're going to put our given in that first box in the dimensional analysis setup. Okay, what we want to be in is grams of H2O, and what we're already in is moles of H2O, and that's going to go down on the bottom so that that will cancel out. Okay, and then our molar mass is 18.015 grams per mole. Okay, we're going to go ahead and then plug this into our calculators, and that's going to give us 57.648. Okay, we have 2 significant figures here, so our answer here should have 2 sig figs, so that's going to give us 58. Okay, moles of H2O cancel as we analyze our units. Grams of H2O is what is left over, and that's exactly what we want to be solving for in this particular problem. Now that we've gone ahead and converted from moles to grams, now we're going to go ahead and look at this next problem. Okay, so this next problem asks us how many molecules of H2 are present in a 1.02 mole sample of H2. Okay, so my given here is going to be the 1.02 moles of H2. Okay, and my solve for is molecules of H2. So in this problem, our given is moles, so we're starting in the kingdom, and we are converting into molecules, so we're trying to go over to atom land. So we're going from the mole kingdom into atom land. We know when we exit the kingdom, multiplication is what's going to happen, and we're going to use Avogadro's number. Okay, so I'm going to plug this in. Okay, so our given goes into our dimensional analysis setup. Okay, So we have 1.02 moles of H2. We want to be in molecules of H2, so that goes on the top. Okay, and we're already in moles of H2, so that goes on at the bottom. Okay, and we're going to utilize Avogadro's number, which is a value that we've memorized. So 6.022 times 10 to the 23rd is that Avogadro's value, okay, per 1 mole. We're going to go ahead and plug this into our calculator. That's going to go ahead and give us 6.142 times 10 to the 23rd. Okay, we have 3 sig figs here. Our answer is going to also have 3 sig figs, so that's going to give us 6.14 times 10 to the 23rd. Okay, moles of H2 cancel, and molecules of H2 is what's left over. And that's exactly what we want to solve for. So again, guys, you check out your given and your solve for. You look at the mole kingdom to help guide you in terms of what kind of math and what conversion factor you're going to use. Check your significant figures, and of course, check your units. Okay, so in this problem, they've asked us how many molecules of H2O are present in a 45.2 gram sample of H2O. My given here is going to be 45.2 grams of H2O. My solve for is molecules of H2O. Okay, so they have given me my starting mass, which is going to obviously be represented by mass land. And they want us to convert into molecules of H2O, which is going to be represented by atom land. So we need to go from mass land to atom land. Now, there is not a direct conversion between these two, but instead what we're going to do is we're going to go from mass land into the mole kingdom, and then we're going to go from the mole kingdom into atom land. Okay, so we're going to go ahead and we're going to be using the molar mass of our water. We're going to divide to get into the kingdom, and then we're going to multiply to get out of the kingdom by Avogadro's number. So we're going to go ahead and set that up. So we're going to go ahead and put our 45.2 grams of H2O into our first box here. Okay, we're going to go from grams or mass land, okay, into the kingdom. So we're going to divide by our molar mass. Okay, so it's going to be what we want to be in, which is going to be our moles of H2O. Okay, and what we're already in is grams of H2O. Okay, so that's going to set us up there. We know we have 18.015 grams per 1 mole as our molar mass. Okay, so at this point, if we stop the calculation, we would be in moles of H2O. But we don't want to be in moles, we want to be in molecules. Okay, so now what we're going to do is we're going to go from the interior of the mole kingdom into atom land. And we do that by multiplying by Avogadro's number. Okay, so what we want to be in is going to be molecules of H2O, and that's per moles of H2O. Okay, and we know that our conversion factor here is Avogadro's number, 6.022 times 10 to the 23rd per 1 mole. Okay, so now we have all of our stuff set up. We're going to go ahead and plug this into our calculator, and that's going to go ahead and give us 1.510 times 10 to the 24th. Significant figures are going to be dictated by this original value. There's 3 sig figs there. Okay, so we're going to have 3 sig figs in our final numerical answer. Okay, and then a dimensional unit analysis. Grams of H2O cancel. Moles of H2O cancel. Molecules is what's left over. Okay, and so molecules of H2O is what we've calculated into with the correct significant figures using our mole kingdom. So now that you're comfortable and have this set up for each of these problems, you want to set up your given and your solve for, use the kingdom to decide what kind of math you're going to need to do, and with what conversion factor you're going to either divide or multiply. Set up your dimensional analysis, check your significant figures, and of course do a unit analysis to make sure that you've set everything up properly.